Today's notes are on dilutions and preparing solutions. So we're going to talk about diluting a substance as well as how do we prepare solutions for laboratory use. So dilutions. Well, what is a dilution? Well, remember when we talked about the vocabulary that we had dilute substances and we had concentrated substances, and that dilute substances were weaker solutions than the concentrated solutions. So we're going to be talking about how to dilute a concentrated solution to make it into a dilute solution. And all that means is that you have to add solvent. So we add solvent to a mixture, it decreases the molarity of it, and we have a more dilute solution. In most cases, that solvent is going to be water. And something to note that's important is when you add solvent, the moles of solute do not change. So, if you remember, molarity is moles of solute over liters of solution. So, if we solve this out for moles, that means that our molarity times our volume, because liters is a measure of volume, is equal to our moles. So we're going to use that idea, this concept here, that moles is equal to molarity times volume, to figure out the new concentration after we add water. And because the moles doesn't change, means the moles before are going to be the same as the moles after. So that means that we can use the equation M1 times V1 is equal to M2 times V2. So M1 is the first molarity, V1 is the first volume, M2 is the second molarity, V2 is the second volume. And we know that M times V is moles, so basically all we're saying is that the moles of the solute are the same. So let's do an example problem. How much 3 molar hydrochloric acid is needed to make 400 milliliters of 0.20 molar HCl? So we're going to start off with, we don't know how much we know our first molarity, so we're going to use our M1, V1 is equal to M2, V2. We know our first molarity is 3.0 molar, but we don't know our volume, so we're going to leave that, is equal to our second molarity, which is 0.20 molar, times our second volume, and that's 400 milliliters. Now in this case, you're not going to have to change these to liters because it just gives us our volume here in milliliters. So we're going to divide both sides by 3.0 molar. And that gives us V1 by itself. Now here we have molarity that cancels out, and that's how we end up with the milliliters as our volume. And we should get that V1 is equal to 27 milliliters. So we need 27 milliliters of this 3 molar hydrochloric acid to make 400 milliliters of 0.20 molar HCl. So now we're going to use that concept plus some other concepts to discuss how to properly make solutions. The first thing you need to know is anytime you're making a solution, we're going to be using this piece of lab equipment, and this is called a volumetric flask. So there's two ways to make solutions. You're going to either make them from a powder or from a stock solution. If you're making them from a powder, it's just like when you make Kool-Aid, you put some powder in and you add water. If you're making it from a stock solution, it's like we just talked about, where you're taking a strong concentrated solution and you're diluting it down to make a weaker solution. So But like I said, either way, you're going to be using a volumetric flask. So things to know about a volumetric flask. They are a very specific volume at this line. So that's the calibration line. And they come in various sizes. You can have a 100 milliliter volumetric flask. You can have a 250 milliliter volumetric flask. You can have a 500 milliliter volumetric flask. You can have a 1000 milliliter volumetric flask, which is the same thing as a 1 liter volumetric flask. And you can also have a 2000 milliliter volumetric flask, which is the same thing as a 2.0 liter volumetric flask. And these are all sizes that I have in the lab that are accessible to me. So the way that you make a solution is you either add your concentrated solution or you add your powder, and then you fill it up to so the bottom of the meniscus is at that line. And then you fill it up with water until the bottom of the meniscus is at that line, and then you mix it up. So that you know that, and the reason you do that is because you know that this volume, this line here, is at whatever volume the size of the flask is. So now, how do we do this from our two different methods? So the first method is from a solid or powdered solute. So we're going to work through an example and discuss how you do it at the same time. So if you need 200 milliliters of a 0.30 molar NaOH solution, how do you make it? Well, first thing is that you need to calculate the mass of the solute needed. The reason you're calculating a mass is because we're dealing with a powdered solute. So the only way that you know how to measure, that we have to measure a powdered solute accurately is with a balance, and so we need to weigh out that amount. So we need to know the mass of the solute needed. Well, in order to do that, we're going to take our concept of moles is equal to molarity times volume. And in this case, the volume does need to be in liters. So, and then we're going to convert that amount of moles into grams. So we take our 0.30 moles per 1 liter, multiply that by our volume is 200 milliliters, but 200 milliliters times 1000, we convert that to liters, that equals 0.200 liters. We're going to pretend that that's sig figs. So that's 0.200 liters. And we end up with 0.060 moles. But like I said, we're not done because we need that to be in a mass. So we're going to take that and we're going to convert it to grams. So we're going to take that and we have 1 mole is equal to 40.01 grams. And that gives us 2.4 grams of NaOH. And then the next thing you do is you add water until you have the desired volume. So the next thing that you would write is you say you weigh out 2.4 grams of NaOH and add water until you have 200 milliliters of solution. And this is actually the answer to the question that was asked of how do you make that solution? The next type of solution that you could be making is you could be making a solution from a more concentrated solution, and that's called a stock solution. So from a stock solution, this is going to be from a concentrated solution. So I'm going to work through an example here as well. How would you make 100 milliliters of 0.50 molar NaOH from a 3 molar stock solution? So the first thing we need to do is calculate the amount of stock solution needed, and we're going to use the dilution equation for that. Just a quick reminder, the dilution equation is M1V1 equals M2V2. So by amount, we mean the volume. So we start off with plugging in our molarities. So we have 0.50 molar times 100 milliliters is equal to 3.0 molar times the volume. And when we're going to divide by 3 molar on both sides. So that cancels out completely. The molarities cancel out, and we're left with 100 milliliters as our units. So V2 is going to equal 17 milliliters. And the second thing you do is you measure, so you actually measure that stock solution and you add water until you have the desired amount of diluted solution. So again, to answer the question of how you would make that amount, you would say you measure 17 milliliters of stock solution and add water until you have 100 milliliters of solution. And again, this is the answer to the question that was asked. Hopefully that clarifies how to make solutions, and if you have any questions, please feel free to watch the video again on Canvas, and good luck with your calculations.